So yeah, again, basically, we're just going to kind of showcase Wi-Fi 6 and MetaGeek products here. So on the agenda, I'm going to introduce myself, talk a little bit about MetaGeek, go over some Wi-Fi fundamentals. And at this part here, I will also talk about some Wi-Fi 6 stuff, some 802.11ax, kind of explain a little bit about how it works. I won't get into too much detail, but I'll kind of talk about it a little bit. And then most of the demonstration today is going to be basically how all of our products showcase Wi-Fi 6. So we're going to look at Insider with MetaGeek Plus, which is a subscription. We're going to look at Wi-Fi 6 and Channelizer, which is more of a deep dive into spectrum analysis. And then we're going to look at Wi-Fi 6 and AirViewer, which is kind of like Channelizer, but on a mobile device. It also has a little packet capture adapter. So we'll take a look at how it kind of recognizes Wi-Fi 6 there. And then finally, I think my favorite one is going to be IPA, which is a packet analysis tool. We'll basically just run some packet captures from my Wi-Fi 6 device and look at it in IPA, which is pretty fun. And then finally, at the end, we will go over some questions. And this webinar is being recorded, so if you want to go back and look at it, we will send this in an email. I think tomorrow is when it auto defaults to send. And then for those of you who missed it as well, you'll get an email with this recording. And on that note, let me make sure it is recording. Yep, it is recording. So about ourselves, my name is Casey. I'm the CX specialist here at MetaGeek. I have a few certifications put on by the CWNP program, which I highly recommend checking out to further your knowledge on Wi-Fi. You can find me on Twitter at Kathy_Fi. And then also with us is Brian Tuttle. He's the CEO and the geek herder here at MetaGeek. And he has a few certs as well. I think I got these right, Brian. I'm not sure, but
yep.
Okay, awesome, perfect. And then you can also find him on Twitter at Geek Herder. He also uses the main at MetaGeek account as well quite a bit. So he's mostly going to help kind of help with any questions, as well as talk about the Wi-Fi 6E, which is kind of an extension of Wi-Fi 6, where we talk about the 6 gigahertz frequencies specifically. A little bit about MetaGeek. We're based here in Boise, Idaho. This is a screenshot from our office. I think, Brian, you might be working at the office today, but the rest of us, most of us here at MetaGeek are working from home. And yeah, hope things get back to normal soon. To dive right in, the FCC allows Wi-Fi to operate in 2 bands currently. Of course, Brian will talk about the 3rd band that's going to be opened up here eventually, the 6 gigahertz band. But right now, it's basically 2 bands, the 2.4 and the 5 gigahertz band. Now, Wi-Fi 6, which is also named 802.11ax, you'll hear me kind of interchange those 2 words. They're basically synonyms. That actually operates in both the 2.4 and the 5 gigahertz band. So it's a little different than 802.11ac, which only operates in the 5 gigahertz band and kind of increases throughput and things like that. AX actually was, it basically works on both bands. It increases the efficiency on both the 2.4 and the 5 gigahertz band and increases the throughput and the max data rate. I won't go into too much detail here. Still, the 2.4 gigahertz band is congested with a lot of Wi-Fi, so we still recommend using the 5 gigahertz band as much as possible. And we'll see where the 6 gigahertz band takes us. Just a quick note on the kind of history of these PHY types, so to speak. The very first modulation scheme used in Wi-Fi was DSSS, which is direct, direct sequence spread spectrum. And this kind of looks like a curve shape on a spectrum analyzer. It kind of looks like this. In 1999, with the invention of 802.11a in the 5 gigahertz band, we had this new modulation scheme called OFDM, which stands for orthogonal frequency division multiplex. And this kind of looks like a square shape, kind of like this, more like a ziggurat shape on a spectrum analyzer. So that's kind of how you know that this modulation scheme is being used. And if you see this, higher data rates are being used as well. We're talking about, at least 54 megabits per second or higher. With 802.11ax, which, just came out this year, this actually uses the same kind of OFDM modulation, but now it's orthogonal frequency division multiple access. And that's what the MA here stands for, multiple access. Basically, as I understand it, it just allows for more devices to kind of communicate. And you know, a lot of the modern access points that are coming out right now with Wi-Fi 6 enabled, they usually have more spatial streams as well. So a lot of simultaneous kind of communications are going on with different client devices. And the max throughput now with 802.11ax, and we're talking on like 160 megahertz wide channel, right? An 80 and an 80. We're talking about 4.8 gigabits per second. So really, really, really fast stuff. And again, I'll kind of demonstrate what this looks like. This is still going to be a curve shape. Excuse my drawing there, but this is still going to be, a square shape. But I've noticed in my kind of tests preparing for this a little bit that the shoulders seem to drop a bit more. So we'll kind of take a look at how that looks on a spectrum analyzer. The current setup I have right now is I have an Aris W31 is the model. It's just kind of the first Wi-Fi 6 access point we really got our hands on here at MetaGeek. And it's 4x4 spatial streams. It's intended for the home user. Kind of disappointing for me. There's not a lot of configuration I can do. It basically auto sets up. In fact, I wanted it to be on channel 1 so I could show you guys how it differs from my own network, which I have set up side by side here. But just upon starting up this morning, it defaulted to channel 11. So I had to restart it until it finally went to channel 1. So a little disappointed I can't configure things like channels. I can't configure data rates, things like that. But I think that's kind of the future of the market is, you know, just kind of plug and play, just, you know, plug it in and it's going to deploy, you know, hopefully the best channels. And configure the best channels. So I can kind of see that being the future of kind of these home user, you know, Wi-Fi routers. And then I also have an iPhone 11, which I'm going to run the throughput test with here. And this is one of the few Wi-Fi 6 devices that are on the market right now. I know the new Samsung phone, the new iPads, obviously the newer iPhones, even the iPhone SE is Wi-Fi 6 compatible. So yeah, we can actually get some true, you know, Wi-Fi 6 to Wi-Fi 6 throughput tests. So pretty exciting for me. The first product I kind of wanted to showcase this in is Insider, which is what we've been working on quite a bit here. The engineering team has put a lot of time into this product, especially Insider with a MetaGeek Plus subscription. And one thing to remember is that Insider uses not only the you know, the chipset in your laptop for Wi-Fi scanning, but you can also add a Wi-Spy DBX, and this will show you spectrum. So we'll also be able to see the spectrum. I actually have one right here, an extra DBX right here. It's just a little spectrum analyzer that plugs in via USB. So we can see Wi-Fi 6, not only from a Wi-Fi scanning chip, point of view, but from a spectrum analysis point of view as well. And also, if you have a compatible packet capture adapter like this Etimax AC1750, then we can start diving into the actual packets and looking at the clients on the network. We just get a lot more analytics if you have this adapter plugged in. And of course, you do need to have a MetaGeek Plus subscription to kind of take advantage of all of these hardware resources. So yeah, Insider is going to show us Wi-Fi 6, you know, from basically those 3 different perspectives. So I'll go ahead and hop in here and kind of show you what that looks like. Yep, so as you can see at the bottom left here, Insider is starting to use these 3 resources, right? I have a Broadcom Wi-Fi adapter, I have an Etimax packet capture adapter, and a Wi-Spy DBX that's helping me out with the spectrum. So that's kind of the three hardware resources that we're looking at. And that's funny, the Wi-Fi 6 router that I've set up actually switched to channel 6. So that's fine because it's still separate from my channel 11. But as we were speaking, it auto switched. So now I know that auto selection is just default built into this access point, which in the Wi-Fi community, that's not going to be people aren't going to like that for sure. But you can see here that I have my Cathify network, which is my starred network right now. And I have that side by side with my Wi-Fi 6s here. This is the SSID that I have deployed for the actual Wi-Fi 6 router. You can tell because the Wi-Fi 6 router is just right here on my desk. And so that's why we see this negative 17 dBm signal strength. It's just right here, basically. My Cathify network is just on the other side of the wall. So I can effectively measure how much my wall is attenuating the signal here based on the difference of these 2 signal strengths. But first thing, I'm going to go ahead and just dive into the Wi-Fi 6s here router and kind of show you the details that Insider shows. for this access point. So I have 2 radios, and this is interesting. I've seen this access point deploy 3 SSIDs before, 3 different networks on 3 different channels. Right now it's only deploying 2, and you can see right now I have you know, one on basically using the primary channel 48 here, and then one on channel 6. And interestingly enough, it deploys a 40 megahertz wide network in the 2.4 gigahertz band. And Brian, I'm not sure if this is I'm not sure if this is a bug in Insider right now, but it says it's using 6 as a primary and 6 as a secondary. And I'm not sure if there's just something in the protocol, or if it's the fact that I'm using a 3x3 spatial stream Edimax adapter, and this is a 4x4 spatial stream access point. So maybe on that 4th spatial stream, we're not gathering the true secondary channel. I'm not sure, but that's a ticket I was going to kind of write up and have our engineering team take a look at and make sure it's looking at 2.4 gigahertz Wi-Fi 6 radios correctly, but I thought that was pretty interesting.
Yeah, that does look like a bug, a visual defect. So it's, yeah, I mean, it's channel 6, so I'm not sure why we have the primary secondary listing there.
Yep. Yep. And so if I select the, we'll look at the 5 gigahertz radio here, and if you click the binoculars button here, you can get a little bit more analytics on the left-hand side. Of course, this is the signal strength over time graph that you're seeing at the top here, but I do have 2 client devices. I have 2 different iPhones associated to this network right now. This iPhone 11 is the Wi-Fi 6 device, and this is just an iPhone 7, just a regular 802.11ac chipset in there. But on the left-hand side, we're getting the analytics of the actual access point, and I thought this was really cool that we were actually able to get this information. So of course we see the AX here. Insider will display AX if it sees it, and it even says Wi-Fi 6 right next to it, which is pretty neat. It sounds like we're calculating the max data rate correctly. We have that, you know, 2041, right? We're looking at the MCS index to calculate the max data rate here. So that looks correct. And we also get the max spatial streams. I thought that was pretty cool because, you know, we're essentially using a 3x3 spatial stream Wi-Fi adapter, which is the highest you can get on the market right now in terms of external Wi-Fi adapters. And it is acquiring the correct spatial streams, which makes me believe that we're probably just seeing that in the beacon. I think those types of capabilities are basically present in the beacon, and the beacon is saying, hey, this access point supports 4 spatial streams. And then we're seeing the current or the max MCS index that this access point can provide, as well as a few basic data rates. Now, interestingly enough, this is a WPA2 access point. It, for some reason, doesn't have WPA3. And then, yeah, it just chooses to auto deploy an 80 megahertz wide channel, which I actually like that. I do think that there's enough space now in the 5 gigahertz band to deploy 80s just right off the bat. I'm curious how it acts if some sources of interference come in, or if it sees too many Wi-Fi networks. I'm curious if it kind of deploys somewhere else. But you can also see here that you know, that you can kind of see the beacon of the 2.4 gigahertz band right here, and a beacon of just a regular 802.11ac here. And I did notice that the shoulders seem to drop a little bit differently. It kind of looked a little bit different. But I'm going to go ahead and run a throughput test here. And the first device I'm going to run the throughput test with is the iPhone 11. And one kind of cool thing too that I'm going to show here first is right now I'm currently associated to the network. If you actually disassociate the client device from the network, so I'm going to go into airplane mode here basically, and you'll kind of see in Insider, you'll kind of see that it's no longer has a signal strength and packets aren't counting anymore. And I'm going to re-authenticate. So I'm going to go back out of airplane mode and reassociate to this network here. And what I'm trying to do is I'm trying to grab an association, which it doesn't look like it's doing. I'm going to try it one more time. I want to get an association request, which gets us a little bit more of the details of the capabilities. There it is. So you guys see that little A icon right next to my iPhone 11. That means that it saw that device just reassociated or associated to the network. And it looks like I roamed as well. So that's interesting. You can actually dive into this stuff if you click client details. Again, if you click the binoculars icon. And basically what we're getting right here is now the signal strength of my iPhone 11. So if I move it away or if I bring it closer, you'll see that signal strength drop, and it's pretty real time because again, we're doing a live packet capture with this. Hey, look, we're getting retry rate. When I was doing testing yesterday, I wasn't able to get retry rate, which I thought was maybe just because it was really efficient, but I'm going to go ahead and run a throughput test. You know, kind of see how Insider handles this right now. So looking for the server, and okay, the throughput test is just firing off right now. I'm getting about 168 megabits per second. And you can see the utilization here, interesting, kind of go to about almost a 40% utilization here. And here's my download, getting about 236 megabits per second. And it just finished up. I'm gonna run one more so you can kind of see how this looks again over time with Insider. And you can kind of see too, keep an eye on the spectrum over here. This is OFDMA right here. This is OFDMA spectrum that we're getting from the WiSpy DBX. And, you know, Insider's only showing us maybe the last 2 minutes, I think is what my time span is selected. So it's not really deep red yet, but we'll use a tool here in a second called Channelizer that will kind of show us that a little bit more clearly. Insider's focus is on kind of the packet analysis and the Wi-Fi traffic. So here's my 2 throughput test, right? This was my download, this was my upload, and then here's my second download, my second upload. It's kind of interesting. One thing I was doing is switching back and forth. We can kind of see here with my iPhone 11 a few capabilities. You know, I'm on MCS 9 spatial streams. I'm on 2 spatial streams. I'm going to go ahead and do the same thing, but on my, let's go back here. I'm going to do the same thing, but go to my iPhone 7. Here we go. So now I'm running a speed test on my iPhone 7 here. And, you know, let's see how much of the utilization. Yeah, 30% here. So it doesn't seem to be utilizing as much. Okay, and I'm going to run that again on my iPhone 11. It looks like I switched, I reassociated to my Cathy-Fi network here. So let me try that one more time here with the iPhone 11 on the actual Wi-Fi 6. Oh no, that looked right. It looks like it actually did. And then that's where that roam came in. It looks like it caught that I roamed from one access point to the other here, but now I'm on the Wi-Fi 6 network and it looks like it actually did stick. So that's kind of what Insider will show for this. We're getting this 3-in-1 perspective, a lot of really cool stuff here. You know, kind of one thing too is if you have MetaGeek Plus Pro, I'm not sure if you guys have been looking over here on the right-hand side here, but there's a lot of pretty fun, you know, packets that you can get. And IPA will also show you this type of stuff, but you can just see how much goes on here. Just tons of different types. I even got my handshakes, 1, 2, 3, 4. Kind of fun to be able to see that stuff. But again, we'll kind of dive into the packets a little bit with IPA. And I want to show you kind of what it looks like from a spectrum analysis perspective as well. And the best tool for that is basically Channelizer. We call Channelizer the deep dive into spectrum analysis, and its main advantage is that it has a waterfall view. So while Insider was kind of showing us a little bit of the last 2 minutes of spectrum, this will actually allow us to kind of take a closer look at what that looks like. And there's also a couple other advantages that I found with Channelizer that I'll show you here in a second when I'm running these throughput tests. So right off the bat, Channelizer starts sweeping the 2.4 gigahertz band only. I want to dedicate the resources of my WiSpy to both the 2.4 and the 5 gigahertz band here. And let's go ahead and hop into the 5 gigahertz because this is where most of the Wi-Fi 6 stuff is operating in right now for my devices. They're clearly associated to the 5 gigahertz band. And the way that Channelizer is showing us Wi-Fi 6 data, I'm going to select my access points here so that they show up, both my Wi-Fi 6 and Cathy-Fi. And we do indeed show here in the 802.11 column, we do show the AX if we see it. And if the laptop is associated to a network, we do now have a green kind of chain link icon that shows up here. But I'm on the Ethernet just for best, you know, most reliable internet connectivity. So we don't see what this device is currently associated to. Looks like we're getting the max data rates correctly as well here. We're getting that 2041 here. So it's very similar to Insider, showing us the correct MCS index and max data rates for Wi-Fi 6. But really, you know, again, with Channelizer, not only will it show us that from a Wi-Fi scanning perspective, but it will show us that from a spectrum analysis perspective as well. So what I'm going to do is I'm going to make sure that I'm indeed on the Wi-Fi 6, which I am. I'm going to run another throughput test here. And you'll kind of see what this looks like, what this OFDMA looks like here from a spectrum analysis perspective. You can kind of see it start lighting up, but really where you see it is this waterfall menu right here. And that's what I really like about this tool is we can go back and take a closer look at this, which is pretty neat. So now I'm on my download or on my upload, excuse me, and my upload never really seems to saturate as much. I'm going to run one more Wi-Fi 6 test on this phone here. And I'm going to also, while I'm doing that, I'm going to change my time span to kind of show that a little bit better here. I'm going to look at maybe the last 30 seconds and you can just see how it's a little bit more red there. And here comes my upload. And then at the same time, what I'm going to do here is I'm going to also run a throughput test on my Cathify network. So I have an iPad here that I'm going to demo here in a second with AirViewer, but I'm going to run another AirViewer or another, I'm going to run another speed test on this iPad. This is on my Cathify network. And it's just kind of fun to see if there's any major differences. So I'm going to run a throughput test on my Cathify network, which is not Wi-Fi 6, it's 802.11ac. And we'll just kind of see if we can find some differences here. So I'm going to go back to real time. This is an AC throughput test. And you can kind of already tell that it's not doing as much to the network here. It's kind of that light green in the waterfall. And I'm just going to run it one more time here. On again, this is on my Cathify network, which is separate from the Wi-Fi 6 access point. So I'm going to bring my time selector down to the Wi-Fi 6 throughput test. And just kind of show you guys what this looks like when you kind of select it cleanly. So this is basically OFDMA right here from a raw spectrum analysis perspective. You know, this is one way that, you know, Channelizer essentially will always be, you know, compatible with the latest PHY types as long as they operate in the 2.4 or 5 or 6 gigahertz bands, right? Assuming we have a 6 gigahertz spectrum analyzer. A lot of people always ask, you know, is Channelizer compatible with, you know, the latest PHY type? And again, remember, it's a raw spectrum analyzer. So if it's making noise, you're going to be able to see it in this sense. And kind of one thing I noticed here is this is Wi-Fi 6. Look at the shoulders. They kind of drop down. We'll see if this is the same here with 802.11ac. Notice how much more clean the AC throughput test is. The shoulders just don't seem to drop as much. Now, and there are a little bit of difference in terms of distance. There's maybe 8 feet between them, and that could be the difference here. But it just looks so much more clean in the AC. It's that the shoulders aren't dropping in, and I wonder if that's part of the OFDMA, the multiple access. Again, I'm going to bring it back here. The shoulders seem to drop a little bit more. You know, I'm not sure, again, if that's kind of the difference in the modulation scheme used, but I did notice that that was a pretty significant difference between, you know, a Wi-Fi 6 spectrum signature versus, you know, Wi-Fi 5, 802.11ac signature. Quite a big difference there. I thought that was pretty interesting. One other thing I thought was kind of fun with Channelizer that, funny enough, I couldn't use Insider to do very well. If I click on physical mode here, I kind of break down each of my radios. I'm going to place a check mark next to all of my my Cathify, my Wi-Fi 6s here radios. And one thing I thought was interesting is the data rates being used. I'm also going to filter out here. I'm going to filter out everything except I just want to see these radios here. I really like that my data rates varied so much in the 2.4 gigahertz. So if I go back to the 2.4 gigahertz band here, and I'm looking at this max rate column right here. I thought this was interesting because I have a studio out back, which is this bottommost line, and it's a second generation Apple Airport Extreme, and or it's an Airport Express, and it has a 144 megabits per second as its max data rate out there. And I have my access point just on the other side of the wall here is a 5th generation Apple Airport Extreme, has a little bit higher max data rates, 216 megabits per second. And this is on the 2.4 gigahertz band. And again, we see this 40 megahertz wide network here, this Wi-Fi 6, triples the throughput, right? 975 megabits per second on the 2.4 gigahertz band. And this is my Wi-Fi 6 router here. So it's kind of fun to use Channelizer to break down the physical radios here and compare my Cathify network with my Wi-Fi 6 network purely from a max data rate perspective. And then of course, once you get to the 5 gigahertz band, I'm looking at about 1300 megabits per second with my 802.11ac. And then again, we're about 2041 with the Wi-Fi 6 router. So a huge difference in throughput. And Channelizer actually does a really, really good job of kind of showcasing those differences, which I thought was pretty neat. Again, this is Channelizer, so this is a Windows-only application. The next tool I kind of wanted to kind of show how this stuff looks is with Wi-Fi Air and the Air Viewer application, which is intended for mobile devices. So iPhones, Android, Samsung phones, basically all of these mobile devices are compatible with this piece of hardware. This is the actual Wi-Fi Air right here. So it is a piece of hardware that you actually have to plug in, and I have one right here to your mobile device. So we ship the Wi-Fi Air with about 5 different cables to make sure that it'll work with your device. So we have a lightning cable for iOS devices, USB-C for Google phones, USB mini and USB micro for the various Android devices out there to make sure that you can connect this device to your mobile device. And this will also show you Wi-Fi 6, not only from a spectrum analysis perspective, but also from a packet analysis and a Wi-Fi scanning perspective. So right now I'm using my my iPad here, which I prefer because it has a lot of really great screen real estate. And we'll open up AirViewer here, and I'll kind of show you. Again, this is very similar to Insider and Channelizer, but this is on a mobile device. This is pretty cool. So you don't have to lug around a laptop, Windows, or Mac computer. You can just use your phone. So right off the bat, it sweeps the 2.4 and the 5 gigahertz. It's kind of showing me my networks. It shows me the network that this device is currently associated to, which is Cathy-Fi. But we're interested in the Wi-Fi 6 stuff. And as you can see, if we hop into here, it will display the Fi type for us. Let me get my annotation tool here. So we do see the Fi type, so we do see AX. I did notice that we don't seem to be getting the right data rate quite yet. And again, I'm not sure if that's if that has to do with the 4x4 spatial streams, and we're using a less spatial stream, a packet capture adapter here. So maybe we're not getting that third or fourth spatial stream. I'm not sure, but again, Brian, this is probably something we'll bring up and see if we can get that squared away. But I've been doing a lot of pretty thorough testing on this stuff. It's great that we at least get the Fi type here.
Yeah. So thanks, Casey. AirViewer is next in line for our Wi-Fi 6 updates that we've been pushing out to all of our software. So new lookup tables that convert MCS index into data rates have to be implemented. And then once those are done, the data rates will be displayed correctly in AirViewer. And then it's just a question of, navigating the App Store release processes for the Apple App Store and the Google Play ecosystem. Then those things will be live. So, probably a few weeks from now.
Awesome. All right. Yeah. Thanks for that, Brian. So this will show you the same it'll split apart those 2 radios. We'll see the 2.4 gigahertz, which does display the AX Fi type there now, and then the 5 gigahertz, which also displays the AX Fi type. And it shows me the one client that I have currently on this network. So I'm going to run a throughput test and kind of show you how this looks as well. So let's see here. Yeah, this should be on the right. Let me verify that this one is on the Wi-Fi 6. Yeah, perfect. I'm not roaming. So I'm running a throughput test. You see the utilization starting to kind of get higher, and we're getting it seems like a little bit higher than what Insider showed, but it's still, all of our tools are still showing that even with this throughput test, there's still plenty of room on this channel, right? We're not even hitting more than 50% utilization when I'm running a throughput test on this device. So that means that more devices could essentially, have these throughput tests as well. That's kind of what that looks like here from just a Wi-Fi scanning point of view. The really cool thing that AirViewer also does, if you go to channels at the bottom right, is it does perform spectrum analysis as well. And if you toggle networks off here, it actually dedicates just full time to spectrum analysis. And so you can kind of see that that Wi-Fi 6 beacon here, that data rate's being used here right on channel 6. But I'm going to go ahead and look at the channel 48 network because I know that that's what my phone is currently associated to. And again, I'm going to run a throughput test here, and you'll kind of see how this lights up. And the closer I bring it to the Wi-Fi Air, bringing it closer, you can just see just how fast the spectrum analyzer is on the Wi-Fi Air itself. Very quick. There's the download, and you just see how quickly that kind of goes up and down. The download usually doesn't do as much. Interestingly enough, I'm going to do that one more time so you can just see how quick it is. So again, nothing, it's light, plenty of time to talk. And then this would be essentially what, tons of Wi-Fi devices on the network would look like. Throughput tests actually do a pretty good job of what a very busy Wi-Fi channel looks like. And you see the red very quickly kind of appear. And then if you toggle networks on, you can actually see those ziggurats, so to speak, here. And it's so close to me, it's kind of funny, it's so close to me, you can't actually see the Wi-Fi 6s here. So sometimes I have to actually attenuate the signal for that to kind of drop down so that we can actually read it. Just because it's for some reason we're getting such a high signal strength from it. And I don't know if that's in the protocol as well to kind of just give us absurd signal strengths, because I've been seeing even -8 dBm or something like that. But let's see if attenuating the signal will drop it down a little bit. It doesn't look like it so far. There we go. There's the Wi-Fi 6s here. So I have to cover up the antenna with my hand to get it to a signal strength that's low enough to actually see it. But yeah, again, you can dive into channel 42 and see my two networks here, which are conveniently placed on the exact same channel on channel 48 as a primary. This is my Cat 5, this is my Wi-Fi 6. So that's pretty much the extent that this tool will show us Wi-Fi 6. Do you have anything to add to that, Brian?
Just for now. I mean, like I said, an update is coming for AirViewer that will have the updated MCS tables for the new guard intervals and the new data rates for 802.11ax, as well as WPA3 identification. So then that stuff will all be displayed correctly. And then I'm sure we can get that bug that Casey was demonstrating with the improper scaling fixed as well. So.
Yep. All right. Awesome. Thanks for that, Brian. And again, it's a raw spectrum analyzer as well. And so if it's making noise on the spectrum, you'll be able to see it from a spectrum analysis from a layer 1 perspective too. So even just having that, I think, is incredibly valuable on mobile. So the next tool I kind of wanted to showcase here is this is a fun one. This is IPA, which stands for packet analysis. And I have a perfect setup right now where both my access points are using 48 as their primary. So we can do a packet capture and kind of show what that looks like from a packet capture point of view. But remember, in IPA, we use kind of these multi-layered pie charts here. So to kind of understand what that means is that very first kind of ring is the actual network, followed by the access point, followed by the client, and then the outermost ring is the actual data. And this was really fun for me to kind of figure out how IPA so far is handling Wi-Fi 6, and as well as kind of the spatial streams. That really comes more into play here because the packet capture adapter turns into monitor mode. Remember that data frames are colored blue, control frames are colored orange, and management frames are colored purple. That's kind of the key here. And this slide is really important because we ship IPA with this packet capture this packet capture adapter on the left-hand side. It's the Edimax AC1750, the same exact one that works well with Insider to do live packet capture. Remember, it's only a 3x3 spatial stream, and it's 802.11ac. There currently is not a Wi-Fi adapter that is AX compatible that that you can plug in like this. They're all like internal. The market just hasn't quite gotten to that point yet to ship external Wi-Fi adapters that are AX compatible or have an AX chipset. So it's almost impossible right now to get a true Wi-Fi 6 packet capture with Wi-Fi 6 adapters unless you have like an enterprise grade access point that is Wi-Fi 6 capable that can spit out a PCAP file. At this point in time, that's pretty much the only way to get a Wi-Fi 6 packet capture. Otherwise, you just kind of have to do the best you can with an AC adapter because, again, it's all kind of backwards compatible to a sense. It's going to recognize that there's Wi-Fi data frames and Wi-Fi packet frames. It might not be able to get everything though, and I'll kind of show you how that works. And it's kind of also compounded by the fact that this is a 4x4 spatial stream adapter. My iPhone is only 2 spatial streams, as Insider told me. I actually couldn't find that online. Insider was the only tool I could find that would show me how many spatial streams my iPhone 11 was using. So we'll kind of see how that bottleneck works as well, because when we dive into full monitor mode here, that 3x3 spatial streams does become important because it will miss anything sent on that 4th spatial stream. And then of course, macOS has really good packet capture adapters, but again, they're still 3x3 and I don't think they've put an AX chipset yet in a laptop, but you guys can correct me if I'm wrong. Yeah, and we are getting some good chats here on, yeah, we are getting some good comments here about this, which I'm excited to dive into later. And then, like I said, you pretty much have to have an enterprise grade access point that is a Wi-Fi 6 access point. You know, Cisco, APs, Aerohive, pretty much all those big enterprise grade vendors, they do have, you know, Wi-Fi 6 access points out there, and they do have the capabilities to produce packet capture files as well. Again, kind of like I was talking about, my Aris W31 is 4x4 spatial streams, so there's going to be a little bit of a bottleneck here. All right, so IPA is pretty great because you can actually, you know, you can open up some sample files, you can open up PCAP files if you do have a true Wi-Fi 6 access point that's spitting out PCAPs, but you can capture natively too in Windows. You just have to click the capture button, obviously. And again, we use that same Edimax adapter. And for channel selection here, Insider told me already that we were using channel 48 as my primary. So that's the channel that I want to scan basically. And again, I'm going to make sure that my, yep, I'm on the Wi-Fi 6 network with my iPhone 11. So I'm going to start a packet capture. I'm going to run a throughput test. And you'll see, notice the packets and the file size. As soon as this throughput test starts, yeah, which it just started, you'll just see those packets just fly through the roof and the file size just gets exponentially larger, right? Just because it's capturing so much data at this point. So I'm going to run a throughput test on here. The download just finished. Here's the upload starting. And then what I'm going to do after this is run another throughput test on my Cathify network and show you kind of what the difference is. So this one finished. I'm going to run a throughput test on my iPad now. This is on the Cathify network, and you'll see the packets here. Okay, it's just starting. So now you'll see the packets flying around. The file size is getting pretty large at this point. And the download is still about halfway through. And here's the upload. And I'm not too worried about finishing the one here. So I'm going to stop the packet capture and let's take a look and see what take a look and see what we got here. What's really cool about IPA, one of my favorite things is that kind of here at the top left, let me get my annotation tool. You can see the airtime for these throughput tests. Pretty obvious that this was the first throughput test. This was my first upload, and then this was my actual Cathify, my 802.11ac throughput test, my download and my upload. So pretty fun to be able to see that from an airtime perspective. I'm also, it's interesting that one had more airtime over the other. That's kind of interesting to see as well. So if I really want to kind of dive into one or the other, I'm going to first focus on the Wi-Fi 6 throughput test here. So I'm going to move my time selector just around that. We'll just do the download only. And this is where it kind of gets interesting. So the very first thing I notice here is here's my Wi-Fi 6 is here, SSID, that looks normal. Then we have this unresolved little part here. And I think this is what the fourth spatial stream is basically doing. I think we can't really get the SSID because it's on that fourth spatial stream. So again, we'll have to kind of wait until Wi-Fi 6 adapters come out to really kind of see what's going on. And hopefully they'll be, 4x4 at this point to kind of handle the multiple spatial streams on Wi-Fi 6. Another interesting thing is, we see the Aris access point, we get the vendor, which is great. We also get the vendor, actually we don't get the vendor on this unresolved. Pretty much everything is unresolved, except we see the CTS. But we get my client, this is my Apple device, right? And notice that we're getting all these block acknowledgements, this red, control frame block acknowledgement. That doesn't look right. If you notice, I'm going to move this time selector over to the Wi-Fi 6 and show you just how much different this one looks, right? This was on the Cathify network. So very first ring is Cathify. That looks great. I have one access point here on channel 48. And then this is my actual iPad that I did the throughput test with. And then notice this is the QoS data, right, from the throughput test. About a quarter of it is the data frames. We still get a large block acknowledgement and some RTS and CTS. But that's what I'm kind of thinking is that, because we don't have a Wi-Fi 6 adapter and because we don't have that spatial stream, we're not seeing the data frame, I noticed. So I thought that was kind of a fun thing to take a look at. We have some other stuff here like this action no act, which I don't think I saw in the, and I'm going to expand this to the whole thing here. This is kind of a really fun part too. I'm going to go just around both of these here. And this is kind of fun to look at and see which access points actually had more airtime. So you can see, yeah, the Cathify, when I ran that iPad throughput test, that had more airtime. That hogged up the channel a little bit more. Whereas the Wi-Fi 6 stuff appears to be more efficient, right? Which is what it's supposed to do. It's supposed to kind of handle transmissions and efficiency better. And this packet capture file kind of proves that in a sense. I guess we do have this unresolved frame, but even with this unresolved data, it's still, a little bit less than half of the airtime was being used on this. Whereas this Cathify and this iPad kind of didn't seem to handle the throughput test quite as well, right? So I thought that was pretty interesting. It's kind of fun, again, to kind of compare this. Again, we don't get that data frame in the Wi-Fi 6 stuff, and I think that's chalked up to the fourth spatial stream. One other thing I thought was kind of interesting is if I look at these, I'm going to go just to the Wi-Fi 6 here. Keep in mind that we show data rates over here on the left-hand side, and we had about 85% of the traffic at 24 megabits per second, a little bit at 14. And I noticed that we actually had some higher data rates being used over here.
So
and,
when I get through it tomorrow,
yeah, let's see here.
in there.
And so if we look at the 802.11ac, we have about 73% at this 24 megabits per second. Then we had a lot of higher transfer rates over here with the AC. And I think, again, this is chalked up to basically just not being able to see these higher data rates with the AC adapter and a 3x3 special stream adapter.
Okay, so we had a couple of questions come up about IPA that maybe you can address.
Perfect. Yeah.
Okay, so let's see. The first question is about when you're setting up for the capture, looks like you can only select the primary channel. Won't that mean that you miss data on the secondary channel for 4080, 160 megahertz channel widths?
Yeah, that's a really good question. And basically, I've been asked that a lot here, kind of handling support. And basically the way that these adapters work, and if I open up a capture here, they're supposed to kind of auto recognize if they're using, anywhere from 20 to 80 megahertz. And I believe that's even the case if it's using 48 and needs to go backwards on the scale, right? And kind of hit 42 and 36 and so on. I haven't been able to do a lot of extensive testing, but kind of the way, Ryan, who's one of our lead engineers here at MetaGeek, basically, the way that these EDMX adapters work and the way that the drivers work, it's supposed to auto recognize anywhere from 20 to 80 megahertz. But if you guys find that it's missing some of that secondary stuff, let us know. Send us a support ticket and a PCAP file so we can take a closer look at it. But theoretically, it's supposed to kind of automatically extend out to capture the entire, at least up to 80 megahertz. I don't think we can do 160.
Let's see. Thank you. And we also have a question about how to see retries in IPA.
Yeah, we do have a retry rate. So let's go ahead and open up this whole airtime graph here so we see everything. And I'll get my annotation tool and show you where that is. Basically, it looks like we had a pretty small retry rate, but which makes sense because I'm basically right on top of my access points. So, this particular file, as I was taking it, had a 1% retry rate over here. To kind of show you something different than 1%, let's open up, lots of virtual SSIDs. This one has a 30% retry rate over the course of this packet capture.
Thank you.
Yeah, yeah.
Then we had one more question, which maybe I answered incorrectly in the text response. Someone was asking earlier about your throughput testing that you were doing when you were first demonstrating Insider. I was guessing that was either something like Ookla speed test or MLab. So then the question is, well, what about if you want to test just the throughput on your network, on your Wi-Fi.
Right. Yeah, and I know for that, a lot of people use a tool called iPerf. They essentially install iPerf on one client device and they put it wherever they want to test the throughput, right? If you want to test the fringe or that very edge of your network, you put it on the edge of your network. And then you have another device with iPerf and you basically run a throughput test via iPerf. I've only done that basically in kind of classes and things like that. I know, Joel, the old trainer here, was very savvy with iPerf, but that's what I would look into if you wanted to test the throughput. Not only obviously from what, because you're right, I'm using speedtest.net, which is giving me my ISP backend as well. If you want to see actual throughput, just from a Wi-Fi perspective, not necessarily being bottlenecked by your ISP backend speed, then I would use a tool like iPerf.